Okay, so this is the card for today. People can see my screen now, yes? Usual story. So this is the last in the series of labs developing the Movies Web API. And there's an archive with this week's lecture notes as well. So let's walk our way through the slides. As usual, I've got quite a lot that I want to try and get through, but so I need to do some more on navigation. There are a couple of the samples left in the set of samples that you have from last week. I just need to talk through those. We also go back to design patterns and explore one of the remaining two patterns that I introduced. Thirdly, I'm talking about global state here. Sometimes there may be a piece of state that's managed by one component, but it wants to make it available to lots of components in the hierarchy. And rather than passing it around as props, which can be inefficient, if we could put it into a space that all, well, potentially all, or those components that need to can actually access it. Number 4, so far the state variables that we've been working on are kind of trivial. They're usually primitives. Okay, there might be an array as well, but often the state might be a more complex data structure, and or the mutation of the state may involve some sort of computation. So if either or both of those cases arise, then there is an alternative approach towards representing state and managing state, which we need to look at. It's another hook, essentially. And finally, then, I want to talk about protected routes, which is part of the navigation set of samples. This idea of having certain routes in our app that are protected in the sense that you need to be authenticated to access them, which is a fairly common kind of requirement. You'll find lots of solutions to that on the web. And in fact, the approach that I'm going to demonstrate is basically one that I found, which I thought was quite nice in the way the person approached it. But by all means, you may Google and find a better solution. So that's what I want to try and work through. So starting off with some other aspects of the React router library that we talked about last week. Right, so one of the main components that the React router makes available to us is the root component. And its interface is, as you see it there, you can specify a path prop and a component prop. They're the only two props that we can pass to our route. So we're kind of limited in terms of what we can express in our route entry. And so I'm saying here that the main disadvantage with this particular interface is, what if we want to pass some custom props to this component here? We can't do it right now. So there is an alternative form of the route component which allows us to do that. And so just by way of example, or sorry, before the example, here's the alternative interface to the route component. So we still need the path prop, but the second one is, it decided to call it the render prop. And the render prop takes a function, and you can have any kind of logic you want to inside in that function. Typically, what you might have is you might initialize some extra props that you want to pass down to the component. The function must return, though, the component that you want to have mounted as a result of this particular route being active. So the function must return whatever component you would normally have specified up here. Okay, so that's the alternative form of the route. And I have an illustration of it in sample 7 of my routing samples. Now, kind of unfortunately, sample 7 is based on an earlier sample, which, okay, were last week. So I'm not covering all of these routing samples in one session, which would make it slightly easier on you, but you can go back and look at sample 7 yourselves anyway, and link it back to sample 4. but the basic idea is in sample 7. I have a route which essentially was this. This is a route I had in sample 4, where I wanted this stats component to be mounted if the URL path matched this. Okay. But supposing I want to pass some additional props to the stats component, maybe in my case, it might be statistical data related to the particular person's inbox, like how many messages on average do they receive per day, how many messages do they send per day, something like that, let's say. Either way, it needs to be computed, and we want to pass it down to the stats component. So that's my objective. I can do it using this form of the route. That's my objective though. And here's how I would use the alternative form of the route to do that. So here's my render option available to me, sorry, here. And it's a very simple, it's a function, and I'm using the arrow function. You can use any form of the function that you want to, but it tends to be the arrow function that you will see used. And okay, my function is simple in this case, in that I'm not computing anything. I'm actually hard coding the statistical data that I want to, or the usage data as I'm specifying it here, that I want to pass down to the stats component. Okay, but normally maybe these things might be computed, and they would be computed somewhere here inside in my function before I actually have the return statement where I'm returning the component. Okay, and so it works just as before. So if the URL in the browser matches this pattern here, then this particular route is active. In the component itself, then the stats component, there's nothing unusual there. You know, I just access the props as I would normally. Now, there's just one thing to be aware of. This function that we pass, this function here that we pass, or sorry, this function that we pass to the render prop, it expects an argument called, and that argument is going to be a props object. And what I'm doing is I'm taking that props object and I'm spreading it out using the spread operator, its individual key value pairs. This props object I'm saying down here is the props object that is inherited from the context in which this route is being used. Okay. Maybe if I just quickly look at sample 7. And maybe if I run it as well, actually. Okay, back to the code. So here's my home page. Nothing exciting there. Just got some hyperlinks just to illustrate what I'm trying to explain here. Here's the basic routing. In fact, I've kept it as simple as possible, right? There's only one route in my main routing configuration. So if the URL is that, then mount the inbox component. The inbox component is implemented here. And this is where I've got the alternative form of the route. So there are nested routes, and you might remember this example from last week. So here I have 2 nested routes. And by the way, now the use of the alternative form of the route isn't restricted to nested routes. You could use it anywhere. I could have used it if need be. I could have used it, sorry no. You can use the alternative form in your main routing configuration as well, but it just didn't arise in my case. So Here's where it does arise though. Here's my nested route, and it's a parameterized route. And as it turns out, in the stats component, I actually want to access that particular parameter. You might remember the parameter is available to me by means of props.match.params, all that kind of stuff. Okay, so I still need to access the parameter. Now, in order to be able to access the parameter, that parameter is actually going to be contained in this props object here. And this props object is inherited from essentially kind of this props object up here. So whatever this props object is in terms of its key value pairs, I want to pass all of those key value pairs, make them available to my function. And I can do that from here. And I also want to make them available to the actual stats component itself. And that's what I'm doing here. I'm using the spread operator to spread out the individual key value pairs. And because that is an expression that needs to be evaluated, I'm just wrapping it in curly braces. That now means that this expression here, props.match.params.id, is now going to evaluate to something meaningful for me. If I did not do this, if I left that out, then this is going to throw up an error. This is going to throw up an undefined error to me. So even in cases where there may be cases where there isn't anything interesting in the props object that's being inherited that is useful to my component down here, it just seems to be standard practice that you pass them down anyway. Okay, so that's how you interpret what is going on here. And again, remember that the props object here that's passed in as a parameter to your function, that props object is the props object that is inherited. That's what I'm saying on the slides. What do I mean by inherited? It's inherited from, in my case, the kind of wrapping component, which in my case is this component here. So if I click on this hyperlink here, and if you watch the URL in the browser, the browser's URL changes to this. So the user's ID, inbox ID is 1234. My stats component is actually displaying 1234. So that proves to me that I can actually access it. And okay, I'm just displaying the actual data that was passed down as well. That's not interesting. Don't want to over elaborate it now, but if I simply take out this, now the only prop that's passed down to my stats component is the usage prop, which means this expression is now going to fail. And if I save it, okay, get a compilation error. Sorry, not a compilation error, a runtime error. And it's pointing at the fact that props.params is undefined. The overriding point anyway is this alternative form of the route. If you want to pass some additional custom components into the component that's associated with the route, then use the alternative form of the route component interface. Any questions about that? No. Okay, moving on. The next aspect of navigation is programmatic navigation. Up to now, the only way we can navigate around our app is by clicking on hyperlinks. And we know that these hyperlinks are implemented using the link component. And we know how the link component works. When you associate a path with the link component, and when you click on that link, the browser's URL changes to whatever path you specified with the link component. And then the routing configuration kicks in and makes a routing decision. So it's all based on that link component. That's the only way we can navigate, but sometimes you want to actually achieve navigation programmatically. In other words, in your actual JavaScript code. So we want to perform navigation in JavaScript. And there are two little patterns, I suppose you could call them. There are two little approaches or options that you have available to you. And it's a question of, it doesn't really matter which one you use, the declarative approach or the imperative approach. There may be certain cases where only one is possible, but in most cases you could use either approach towards implementing programmatic navigation. If you use the declarative approach, I'm saying there that you have to actually introduce a state variable into the component that's going to perform the programmatic navigation. And the only purpose of this state, sorry, not a state component, a state variable. You have to define a state variable. And the only purpose of this state variable is to allow you to make a decision on your navigation. And you use the redirect to component provided by the React Router library to actually implement your programmatic navigation. The imperative approach is where you use the withRouter function that we saw the last day, and you use a special props function really called history. History is a function that is available to our component that wants to carry out the programmatic navigation, but this history prop is only available if you use this withRouter function. So it's one of these additional little extra props, and its specific purpose, this history prop, its function, its purpose, sorry, is to allow you to perform programmatic navigation. By way of illustration, we're moving on to sample 8. A typical kind of use case for programmatic navigation might be registration. Okay, so that's what I'm illustrating here. So I've got these two registration links in my header, and I've got two of them because I just want to implement the registration using both approaches, the declarative approach and the imperative approach. But the way the registration works is if you click on either of these links, you're brought to a registration page and you fill out your registration details, which I've left out because they're not of any interest to us. Then typically you click your register button. Clicking that button is going to trigger some event handler in the component behind this page, and it's going to do its thing. Maybe it's send data back to a web API, whatever, maybe do some validation. And if everything is okay, then we want to redirect the user back to the home page. In other words, we want to do that. Now, this last part is where we're going to implement programmatic navigation, because this is going to be carried out by the function that runs when we click the register button at the very end of that function, presumably. Yeah. So how do we implement it imperatively, and how do we implement it declaratively? So if we look at sample 8, which is where it happens. And again, I've kept my sample as narrow as possible. So here's the only routing configuration that I have. This route is going to be triggered when the user clicks the register button where the registration is implemented declaratively, i.e. the programmatic navigation is implemented declaratively, and this one is associated with the imperative. So let's supposing I click on the imperative. You can see what the URL changed to. And when I click on this, then it brings me back. Okay, so the main component that we need to look at is just going to close off some files here first, sorry, now before I sorry, now there are things just popping up in front of you on my screen, so that's why I'm stalling. Okay, this is the component that displays my registration form, and it's going to implement the programmatic navigation in an imperative approach. So the first thing to notice is that I'm using the with router function here. I'm using that, and I'm passing my implementation to it, so it returns another component, an enhanced component, and particularly that enhanced component adds a history prop and makes that available to my component here. And so what am I doing inside the actual implementation itself? This is the function that runs when the user clicks the registration button. This is the actual registration page itself, nothing on it of any interest, except the only thing we're interested in is the registration button itself. When we click that, that triggers this function. And here's how I implement my programmatic navigation. Right. Props.history.push. Essentially what push does is it pushes this path onto the browser's URL address bar. And of course, in my main routing configuration, I have a route entry associated with this, and it sends the user, or it mounts the home page, which is exactly what I want. So that's my imperative approach towards implementing programmatic navigation. That's one example of it. In case of the declarative implementation, in other words, when I click on this one up here, exact same behavior. How did we implement it? It involves using state, and the purpose of the state is to help us make a decision within our component as to whether we need to kind of redirect or not. So here's my state variable, which I've just decided to make it as a Boolean. I've initialized it to false. Here's the function that executes when I click the registration button. What does it do? It changes the state to true, and I've got a very simple decision here, and my decision is checking to see what is the current value of the state variable. If it's equal to true, then I essentially want to send the user back to the home page. I want to redirect them back to the home page, and I'm using my redirect to component, which is a declarative form of achieving redirection, and specifying what I want, where I want them to be directed to. So that means that when this component here mounts, every time it's going to make this check. And because I've initialized my state variable to false, the first time this component mounts, this expression here is not going to be true. So it's going to skip over it, and it's going to render my registration form. Eventually, the user clicks the registration button. My button on click handler executes. It changes the state, which means my component re-renders. This time it re-renders, and now this expression is true. And so my component is returning this JSX instead of returning this JSX. But when you return a redirect, the effect is as I've explained. So that's a declarative approach towards implementing programmatic navigation, which is really the purpose of this illustration, nothing to do with implementing registration forms or anything like that. And we use programmatic navigation in this week's lab, I think. Now, there is one other sample, navigation sample in my list of samples, but I'm not going to cover it here. I'm going to cover it towards the end of the lecture. So this is kind of summarizing everything that we know so far about implementing navigation in general across the React framework. It tends to be very declarative in nature overall, in the sense that we have all of these components that allow us to express our routing and navigation requirements. There was an earlier form of the React Router library which was much more imperative in its approach. And there's a lot of component composition going on behind the scenes, which is, again, central to the kind of the React way of doing things And also the React router kind of follows that kind of pattern of event, state change, re-render, not just in the case of programmatic navigation, which we just happen to have there, but there's a lot of this happening as well behind the scenes. Like, for example, when I explained there, when you click on a link, that changes the browser's URL address value. That event causes the React router browser router to respond to that event. So that's happening behind the scenes. That's kind of following the event, and there's a lot of state management going on inside in the React router components themselves that we don't see, but it does follow the kind of the React way of doing things, as I said. So these are some of the main components that we've looked at, and there aren't many others, to be honest. And we've also seen this use router function, although we now know it's what's called a higher order function, and it makes routing related props available to our components. For example, these guys here. We've seen all of them. The only one we haven't seen is this props.location, which arises in a later sample, as it turns out. So that's navigation put to bed. Now there is actually, I think I'm using React Router version 4 in the labs and in the movies app. There is a newer version, version 5, which you may come across, and you know, it does everything that 4 does. The syntax is slightly different. It's still all of this kind of declarative component composition, follows all of that. But if you do come across it, then that's fine. You can use it. It's pretty easy to work out what the version 5 changes might be. But I am using version 4 anyway. And really everything that I've taught you or covered in relation to navigation, I think covers any use case that you may need in your assignment, which is really all you're immediately interested in. Back to design patterns. This is a slide we have from last week. I won't talk my way through all of this again because it was only last week. In particular, what I want to look at is this pattern, the render props one. We looked at composition, like the container pattern last week, and it's all about both container and render props. Kind of they're targeting the same kind of use case, which is reusing code components within your code base. So where does this term render props come from? And by the way, we've actually seen an example of it already. You might remember that in the root component that we were looking at there a moment ago, this new prop that it had was called render. And that's because the React router actually implements this render props pattern behind the scenes. That's kind of by the way, but let's just imagine now we hadn't seen that, and this is our first introduction to this render props pattern. So what is it's about? Again, as I said, it's about sharing logic between components. In other words, reusing logic. And our render prop, in dry kind of definition terms, a render prop is a function. So it's a function that we pass into a component, and the receiving component calls that function, and what the function returns is JSX. So the render prop that you pass into a component essentially kind of tells the receiving component what it should display. Okay, so it's the render prop is actually contributing to the receiving component's JSX. The receiving component may still have its own JSX, but the render prop is providing some additional JSX. So we're essentially injecting what we want a component to display for us. Here's the simplest kind of use case. So here's the component now that's going to be shared across my application, Maria, and it's as simple as I could keep it. But you can see here in its return, in the middle of its return, it's going props.render. Sorry, it's going props.render. So it expects to receive a prop called render. By the way, naming the prop render is not significant. You could call it anything you want to, but the convention, because of the name of the pattern, the convention is to call the prop render. other than that, it has no significance. So we're calling props.render, and look, we're actually calling it as a function. So it must mean that whatever this function returns, that's going to be inserted inside in this overall JSX. So whatever component is using this, the component that is using it is going to provide the render prop. And so the component that is using it is actually passing in some JSX into this shared component. Here's an example of a component that is using it. We would refer to this as the consumer, as the term I mentioned the last day. So in this case, the consumer is okay, it's using my shared component, and here it's initializing the render prop, and indeed it is passing in a function. It's a very simple implementation of a function, but it is a function using the arrow syntax. And in this case, the function returns this little span. Now, again, there could be some logic going on inside here, but the function must return JSX. That's the requirement I probably should have mentioned in the previous slide. It must return JSX. In this case, the JSX is just that span. So when this overall component kind of executes, this is what is generated, and this is what it displays, if you like, on the screen. You've got your div with your span inside in it. And okay, the div has a mouse over. That's presumably that this is the kind of part of the shared logic that I want this mouse over functionality, and I want whatever this class does in terms of the CSS, I want to reuse that logic many times in my application. But in this particular example, I want to use it in order to make this span something that I can mouse over. Yeah. Now, what the mouse over function does is not important. That's dictated by this shared component up here. And what the class does is also dictated by this component up here. So that's 101 case of render props pattern. Here's another kind of example that I just kind of tried to dream up. So I've got this React app for displaying the blog posts, typical kind of use case. And I'm saying that supposing in this app that's related to managing blog posts, I have two views. One view that displays the text of a blog post, followed by a list of hyperlinks to comments that people have posted about the post, about the blog post. That's one view. And I have a second view that displays the text of the blog post, but this time it's followed by a list of hyperlinks to related blog posts or matching blog posts. So they might be two typical kind of views that I want in my blog post management application. But in the way that I've described the 1 and 2 there, clearly there's a lot of commonality between view 1 and view 2. Here's how you might approach it if you didn't use the render props pattern. And again, I'm only giving you excerpts from this now, so there's obviously bits that you've got to fill out in your head. So let's say this is the component that displays a list of comments, and it's passed in by means of the props. It's probably passed in some information in order to allow it to work out which particular comments it should display. Maybe again, it talks to a web API, passing it the ID of the post, blog post, blah, 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 all that kind of stuff. That's not important. And presumably I've got a component that also just displays a list of matching blog posts, which I've left out here. And here then are the two components that render my two pages. And so this is the one that displays the blog post and the comments. So, okay, this component presumably actually displays the text of the blog post. And here I'm using the comments list component on the top there. Whereas down here, this component is also using the text block component, but in this case, it's following it with a component that displays a list of matching links to matching blog posts. And presumably the logic that's here and the logic that's up here is actually, pretty much identical. It's common between these two components. And certainly the structure of the JSX looks very similar as well. So there is, we would say that our code between this component and this code and this component, the code is not dry. There is repeating code going on there. In order to use the render props pattern, then this is how we might approach it. So here's the shared component, right? And you could, that's an error there. Actually, I shouldn't have this dot props. That's a throwback to an earlier version of React. Really, we don't use that anymore. So just get rid of that. It's just props dot render. Okay, but here's my shared component, and the logic that's here presumably is taken from here. And clearly this structure here resembles this structure here and this structure here. And here are my two views then, and they are using the component on top. And so in one case, the render prop is passing in the comments list. So the comments list gets inserted here, whereas the other one is passing in the component that renders a list of matching blog post hyperlinks. So the blog post is the, what am I saying? Is told, yeah. This kind of guy is told what it should include in its JSX by virtue of this part here. And it's being told by our two consumers. I used the render props pattern in this week's lab. As you'll see, the movie card, I reuse the movie card in my homepage. I use it in the favorites page, and I'm also going to use it in the upcoming movies page. But the actions that I want the user to be able to carry out on the card are different for those three views. By actions, I mean when the movie card is being used on the home page, the user can click the heart on the bottom left of the card in order to tag the movie as being their favorite. Whereas when the card is being used in the favorites page, I actually want to allow the user to click a button that allows them to write a review, or else click a button that allows them to delete the movie from their favorites list. Okay, but other than that, the card is, the bulk of the card's code is reused between those two views. And similarly, the upcoming movies page has different kind of actions that it wants to allow the user to carry out. You'll see it in this week's lab anyway. The function that you assign to the render prop, it quite often can be parameterized. In other words, it expects an argument. And I'm going back to the 101 case to try and illustrate that. So here's the shared component that we had from 2 slides back. But you can see this time that the render function is actually passing an argument to whatever function is passed into it, and it happens to be a person's name. Here I'm using it, and sorry, no, the person's name is somehow determined up here, maybe by talking to a web API. That's not really important, but I'm passing a person's name into the actual render prop function that's passed to me. And it's only this component actually knows how to determine the person's name or how to acquire the person's name in whatever it does up here. Here's the consumer, and the consumer, is passing the function as before, and it's indicating, look, the JSX or the code that's in here expects an argument to be passed into the function and is using it somehow. In my case, it's just using it as part of the span. But whereas this component expresses what it wants to have displayed on its behalf, it's the component up here that actually determines what is the value for this parameter to the function. That's the kind of way it works. And that actually arises in the lab this week. So you'll see more tangible example of it. What is left then in my 3 patterns are higher order components. I'm not going to look at an implementation. I've already kind of alluded to what the idea of a higher order component is already, even though its name is a bit misleading. A higher order component is not a component, it's a function. And it's a function that takes a component, one of your custom components, and it enriches it in some way. And I'm specifying here the typical kind of, the typical kind of enhancements that a higher order component function might do. It actually might receive a stateless component and make it stateful, or as we've seen, it might make additional props available to the component that you provided with, or it might just add something to the UI of the component that you pass into it. Yeah. So the width router is one example of that. I think there was another example of a higher order component that I used in the labs, which comes from a third-party library, as it turns out. And if you want to, you can Google higher order component to see actual implementations as to how you might actually achieve this. That's optional, really, though. Right, that's design patterns, although we're not completely finished with it. The next topic, complete change of tack now, I want to talk about is React contexts. React contexts have been part of React from day one, really, but it's only since they introduced hooks into the React framework that it made these contexts more accessible, I suppose, to the developer. And it's only since hooks have been introduced that developers have started using this idea of a context. What it actually is, and it's kind of linked to patterns, is it's an implementation of yet another pattern called the provider pattern. This pattern has nothing to do with reusability or anything like that. It has a very different kind of use case, which I'll explain in a moment, but it is linked to patterns in that sense. And the provider pattern, like many of the other patterns, are not unique to React. They're not unique to web development. They could be applied in other areas of software engineering as well. I suppose, to be honest, to be fair, obviously the render props and the higher order component are very specific to the React world, or certainly the web world, although higher order component, not necessarily. Actually, now that I think about it, it's really an abstraction of some other more general purpose patterns. The render props, I'd say, is kind of unique to React. All right. The provider pattern is not, though. So what is this provider pattern and when would we use it? And it has a very specific kind of use case, and it is if you've got data that you want to make available to lots of components. Let's talk about it in the context of React now, and it tends to be state data. If a component has state data and it wants to make that available to lots of other components in the hierarchy, then rather than passing that state data down as props, we can use a React context to store it in there, and the other components can access the data via the context. Okay, so it's for sharing global data, global state data. It tends to be state data. It could be data that's computed from state, but directly or indirectly, it tends to be state data. Typical example would be this, right? You retrieve data from the web API, and lots of components need to know that. The other typical example would be if somebody has logged in and lots of components need to know who is logged in, or is there somebody logged in, then that would be another example of global data that lots of components need to have access to. The second one then is kind of related to the first one, and it's very specific to React. We use the context I/stroke provider pattern to avoid something called prop drilling. Here's a little picture that I found somewhere on the web, and sorry now about the emojis stuck into it, but it kind of illustrates what's this thing called prop drilling all about. Prop drilling is something that we want to avoid. And so what the picture is telling us is, I've got a component at the very top, and it's a stateful component. And certain parts of the state are required by components further down the hierarchy. So this component way down here needs to know about certain parts of the state, and looks like this one here does and this one here does. Now, if we didn't have the provider pattern, the only way we can make the particular part of the state available to the other components is by passing them as props all the way down. And the assumption is that these intermediate components here aren't interested in the prop. So they're merely only transporters of the data down the hierarchy. And that's why the emoji is getting sadder and sadder as it goes further down. Okay, the prop that's being passed down, it could be data, but it could be a function as well. This might have some functionality that for whatever reason is actually invoked by this component way down here. And so the only way it can invoke it is if it's passed down a reference to that function. So prop drilling is this idea of passing props all the way down a hierarchy for the purpose of making it available to components that are further down in the hierarchy. And that's something that we try and avoid. It's kind of a code smell, I suppose, if you like. So how do we implement this provider pattern in React? We're back to the React world. And there's 3 parts to it. And these 3 parts are kind of applicable in other domains as well. So number 1, we need to declare a component for managing the state, the global state data. Okay, that's fine. We know what that, we've had those kind of components already. Every component, every stateful component is responsible for managing its own state. The state in this case tends to be a state associated with a component very high up in the hierarchy, but it's still just an ordinary stateful component. So it's going to use the useState hook, presumably, to acquire the state. Now we tend to call that component, because it's used in the context of the provider pattern, we tend to call it the provider component, but it's still just an ordinary stateful component that acquires its state data in the normal way using the use state and use effect hooks. Number 2, this is kind of vague right now. I'm saying that I make the data accessible by other components using something called a context. So I need to elaborate on what I mean by that. But for now, let's say that a context is a construct where we put the state data into, and other components can then access the data inside in that context. Number 3, we use component composition to integrate the provider with the consumers. The consumers are those components that need to access the context. But I'm saying here that we use composition, and it turns out the type of composition that we're going to use is container pattern. So we're going to reuse that. So that's in very general terms. They're the elements that make up the implementation of my provider pattern. I need a provider component. I need something called a context. And thirdly, I need to integrate my provider with the other components using composition. To drill a little bit deeper, this thing called a context, this is the glue behind the provider pattern, okay? A context provides a way to pass data throughout the hierarchy, okay? Then that's still a bit vague, rather than passing them manually. The provider component, it's the one that needs to create the context construct, and the consumers access the context using a special hook. And the special hook is called the use context hook. So we're getting a little bit closer now. So we've got a new hook that we need to introduce, and we need to work out, well, how do you actually create a context? This is my visualization now of what a context kind of gives us when we manage to implement it. So my context is my orange box on the top left. So it's kind of outside of everything really. And the provider, which tends to be, doesn't have to be, but the provider tends to be very high up in the hierarchy. It's the component that's going to be responsible for putting data in there. And these consumers can access the context by using a special hook. So there's no more passing data down along the hierarchy. That's just a visualization though. Here are the bits that make it up. Finally, we can see some code. So here's an outline of a provider component. First thing to say is that it's just an ordinary component. It has some state management logic inside it. That's using the use state and use effect hooks, presumably. The next thing to note is that in the same file, it doesn't have to, it tends to be in the same file, we have a statement like this. So this statement is simply creating a context. If you like, it's creating an empty orange box from my previous slide. Okay, so that's how you create a context. And we create it outside of the component scope. The slightly ugly part then is what's going on here. What I'm doing here is I'm referencing the context construct, because some context here is the name I gave to this variable. By going some context.provider, I'm essentially associating the context with the provider. And what I'm doing here, and again, I would admit now that the syntax is a little bit clumsy, but what I'm doing here is I'm specifying the particular, I'm exposing the particular parts of the context that I want to make available to the rest of my components. So this values prop, you assign it an object, a set of key value pairs. The keys can be whatever you want them to be. The values will be referring to some particular parts of your state, or a value might be referring to a function that you've actually declared inside here. And by associating that function or that particular part of the state, by associating it with a key inside this object, and by then associating that object with this values prop, that's how we essentially expose the contents of the context to the rest of my component hierarchy. So creating the context is fine. That's just creating an empty context, but it's here is where you declare what goes into the context, if you like, and thus what is available to the rest of my components from the contents of the context. Not the nicest syntax in the world, but there you go. The last thing to note is I'm using component composition here. So I'm going to be composing this component with whatever is nested inside it. Here's where the composition is actually happening, where we tend to use the provider component. Here's where I'm referring to the provider component. We tend to use it in the same component that contains all of my routing configuration. So it really tends to be the very top component in the hierarchy. You can have contexts that are associated with components further down the hierarchy, but remember, those contexts, or a context in general, can only be visible by components that are further down the hierarchy than the actual provider component that is responsible for managing that context. So if you want to have your data available to the entire rest of the application, then the provider component tends to be at the very top of your hierarchy. So this is where the composition is going on. You can have anything you want in here. As I said, you may actually, and you will see this in the lab, you'll have your routing configuration inside here, which means that really the rest of the entire application, because below the routing configuration is where all our pages and our custom components are. So effectively, the entire application can now access the context that was defined by this component up here, or exposed by this component by virtue of the previous slide. The last piece of the jigsaw is the actual consumers. And here's what you need to put into the consumer. This is where you use a special hook called use context hook. And you use the hook and you specify the particular context, because you may have more than one. There may be a number of contexts. and there will be 2 in our case in the movies lab, as you'll see. So you need to, I don't have it. Oh, sorry, I'm here. I'm importing the context. If I might just flip back for 1 second. What I'm importing here is not the provider component. What I'm importing is the actual context construct that I created, which is this thing here. So you import the context, and you also import a special hook called the use context hook. You use context hook, you pass it the context reference that you've imported. That returns essentially an object. And here again is what the important point. This object reference here is pointing at the same object that you created here. Now, if you're slightly confused, I'm not surprised. I'll pause to allow you to ask questions, but you really need to see this in action, and you will see it twice in this week's lab. So here's the consumer anyway, and this is how you access the context construct. So there's a lot of moving parts to it. And I think when you see a real implementation of it and stand back from it, that hopefully you get the idea. I'll pause anyway, just in case people have any questions, but it's quite tricky and it's not the cleanest implementation possible, but it's what we have to live with.
Hello.
Mm-hmm.
I said it seems similar to this. In fact, I think Redux might be a context like library almost.
Yeah, so this is an alternative to Redux. So you so in the very first lecture I said that React was all about the V part of MVC, but I did actually say back then as well that more recently the React framework has started to move towards the M part as well as the V part, as in the model part, and contexts are associated more with the M part of MVC. So Redux, context is an alternative to Redux, is the short answer. Although you will read online, you hear people saying you should not use context for storing state data. And you'll get an equal number of people say, oh no, I do it and it's a great idea and it's benefited the structure of my code, blah, blah, blah. So there is a bit of an argument as to whether you should use context for actually storing state data or not. And the React team themselves don't come down either way on it. But rather than confusing the whole debate now, let's just stick with the line that a React context is really an alternative to using the Redux library. The only addition I would say is if your state that you're trying to make globally accessible is quite complex, then you may be better off using the Redux library rather than using the context approach. But if you're not thinking beyond this module, then context is fine for managing global state. Was there anything else? No. Okay. This slide is just for completeness. And it really more relates to using the context in a production development environment. You should not use the context just to avoid sending props down 1 or 2 levels, to avoid prop drilling that's considered kind of shallow. It's only if you've got a very deep component hierarchy and you want to pass props from something very high up in the hierarchy to something component very low in the hierarchy. Rather than actually doing that, then use the context approach instead. Now, I kind of break that rule because in the lab, I think there's only maybe 1 or 2 levels of depth in my movies app component hierarchy, but I did want to illustrate the implementation of the context and the provider patterns. So that's why I used it in the labs. Number 2, don't just put anything into your context. Make sure it is data that is really used by many other components. If you find yourself putting state data into a context and there's only one maybe other component that needs to know about it, then that's not a good idea. And number 3, if the key value pairs in that values object, the values can be anything. They can be primitives, they can be functions, which they are in the case of the movies app, as it turns out. Or they could be arrays or objects or any kind of complex data structure. If it is a complex data structure, then you need to be careful because you could actually impact on the performance of your app as a result of putting a complex object structure as part of a context that you are sharing across the component hierarchy. You need to rethink. Maybe you should go back to just using ordinary prop drilling. And that's just something that you can only determine by doing performance measurements of your app's performance. So anyway, we needn't worry about these things really for the purpose of this module, and for the purpose of the assignment. I won't be assessing these things on the assignment because we haven't looked at performance at all and measuring performance, but it's just for completeness, as I say. Another topic, which is actually kind of linked to context, is another hook called the use reducer hook. And the one-liner is, the use reducer hook is an alternative to the use state hook. So the use reducer, and when should you use the use reducer instead of use state? And it is if your state structure, if the structure of your state variable is something non-trivial. Up to now, I think a lot of our state variables have been primitives. The only exception is we are storing an array of movies in a state variable, so I suppose that would not be considered trivial. But in general, anyway, if your state variable, if a particular state variable is non-trivial in terms of its structure, number 1, and or how you mutate that state, if the mutation of the state requires some sort of computation, then maybe you should not manage the state using the use state hook. You should manage it using the use reducer hook. So there's 2 kind of scenarios, and they're kind of interlinked. Non-trivial state data structure, and the mutation of the state variable is a computation that's non-trivial as well. And I used the use reducer hook in this week's lab. I essentially move the array of movies that we get from the discover endpoint. I move those, A, I move them into a context, and B, I use the use reducer rather than the use state hook for managing the array of movies and the mutation of that array. And as we just mentioned there a moment ago, the use reducer is actually based on a lot of the ideas from the Redux third-party library. The Redux library, for those of you that haven't come across it, is a library that tends to be used an awful lot with the React framework. It's a completely separate library, managed by a separate team, if you like, although recently I think React actually released or open sourced their own form of a Redux kind of alternative. So as well as having context, they have another library as well that you can use. And what Redux is all about is, as I'm saying there, it's about managing application state data within your browser. State data, by application state data, we tend to mean data that you get from an API, a web API, where do we store that? Where do we manage that data within the context of our React application? But maybe we could use this Redux third-party library to code that storage and management. Although now what I'm saying is we can use the use reducer hook, which is part of the React framework, and a context, which is also part of the React framework, use those two things to manage our web API data instead of using the Redux library. Back to our use reducer hook. Its signature is very like the use state hook, not surprisingly, because they are just alternative approaches. So the use reducer hook, you've got to pass it the initial value for your state variable. That's the same as before, as with the use state. But secondly, you need to pass it something called a reducer. A reducer, as we'll see on the next slide, is a function that you implement. And in the implementation, that's where you express programmatically how your state variable mutates, how it changes its value. Because I said at the top of the slide there that when the mutation of your state data is something that needs to be computed, then where do I put that kind of computation? Well, the answer is you put it inside in this use reducer function. Sorry, the reducer function. What the use reducer returns is very similar to what the use state returns. It returns the new value of the state whenever you mutate the state. And it also returns something called a dispatcher. A dispatcher is also a function. And really, as we'll see, what the dispatcher does is the dispatcher initiates the state mutation. The reducer actually contains the implementation of the mutation, but the initiation of the mutation is done by invoking this dispatcher function. So there's a couple of kind of what I'm calling constructs involved here in this whole discussion. We have this notion of state, which we're familiar with. And it is mainly where state is non-primitive or non-trivial. We've got the reducer function, which I've alluded to a moment ago. We've got something called actions. Actions, you can think of them and have more detail on them on the next slide. Actions kind of are the events that would trigger a state mutation. And finally, we've got a dispatcher. So there are the four kind of constructs. And these names, dispatcher, reducer, state, these are all terms that you would see used if you read anything about the Redux library. So that's where it's coming from. And that's kind of further stresses the point that the use reducer plus the context are all kind of doing the same thing that the Redux library does for you. So a bit more detail, some of it is a little bit repetitive though. So the reducer is this function that you implement. It's a custom function that you implement, and its purpose is to express in code how your state mutates or changes. So you implement it, but you have to follow a certain set of rules. And if you don't, then it just doesn't work. Number one, the function, its signature has to be like this. It expects two arguments. The first argument is the current state value. And the second argument is something called an action. And what it returns is the new state. We'll see a little bit more on the action in a second, but the function uses the action to determine how should it mutate the state. So given that it receives the current state and is told what action should be carried out on that state, then it knows enough in order to carry out the mutation. And what it returns is the new state. Now, these are very important points here, right? The current state that is passed into it, that is immutable, which means the only way we can return the new state is by making a copy of the current state and modifying that copy. And it is that copy that we return. That's the kind of pattern that you have to follow in your implementation of this reducer function. Okay, you receive the current state, you make a copy of it, and you change the copy and you return the copy. That's the outline. These reducer actions are just actions. They tend to be just objects. And again, these are custom. These are specific to your particular React application. They're objects, and they tend to have just two key value pairs. One is stating what the nature of the action is, what type is the action, and the other is any data associated with that action, which we call the payload. And so an action is something that we pass to our reducer, as indicated up here. And there will be different types of actions for your particular problem domain. And that's something that I guess you determine as part of your design and your modeling. What are the different types of actions, and what is the payload associated with each action? And then what is the change that needs to happen to the state if that action is triggered, if you like. So as I see here, the the reducer function uses the actions type, it uses the action type, the first part of the action object. It uses that to determine what type of mutation it should carry out. And it uses the payload then to determine the actual mutations that should happen. So as we'll see in the lab, the reducer function, all it tends to be is a case switch statement, where the cases are linked to the different types of actions that you have identified for your particular problem domain. The last part is this dispatcher. The dispatcher is a function that's actually returned to you by the user reducer hook, so you have no control over that. It's given to you. And you use this function to trigger a state change. You never actually invoke your reducer function directly in your code. You never do that. What you do is you use the dispatcher to do it on your behalf. And the dispatcher's invocation looks like this. Okay, so the dispatcher is a function that you get, and you simply pass it a particular action object. And what the dispatcher does is it calls your reducer function, passing in the action and also passing in the current state. The dispatcher has access to the current state because if I go back to the previous slide, the dispatcher is actually constructed by the user reducer hook, and the user reducer hook is also kind of responsible for managing the actual state data. So by consequence of that, really, the dispatcher is also able to access the state object structure itself, wherever it's stored, and it's stored as part of the user reducer's internal kind of the user reducer's internal variables, if you like. Now, I have one example application demonstrating all of this. And it was a great idea that came to me back in March, April, when we went into our first lockdown. So it's this glorifiedly titled Zoom Party Manager. It's nothing like that, but that's where the idea came from. So to get access to this code, go to the website and grab this archive here, download it, unzip it, import it into VS Code, and run npm install and npm start. So it's a Create React app. And so if I do that, just need to clean up here first, sorry. So I'm using the random user web API here again. And so this was my great vision back then. So I've got my 10 friends, and they're all listed here initially. And I've invited them to a Zoom party. And as they confirm their attendance, then I just click on them and they get moved over to the list on the right. I can tell you're impressed. If they subsequently come along and they cancel, then I just click on them and they get moved back to the list on the left. Okay, so that's the behavior. Now my list of friends is going to be my kind of state. And in terms of actions, there are two types of actions. A user has confirmed that they're going to attend. And the other type of action is where a user cancels their confirmation, if you like. And the payload in the case of both of those actions is just, let's say, the ID of the friend. It's simple enough, really. Right, so that's the behavior. Let's have a look at the code. Okay, so there's something interesting here in that file, index.js. This is where I'm using the user juicer. So this is the one that we're really interested in. Before I look at the detail of that, here's a friend component. Okay, so very little there. So this is the component that I use to render each of these here and here. And the friend list. The friend list component is the one that's responsible for generating either the list on the left or the list on the right. And of course, the event handler, when I click on one of these here, the event handler is going to be responsible for initiating the state change, for initiating the mutation of my state. My state in this case is my full list of friends. Okay, and the action, the event handler associated with clicking on one of these here is going to be different from the event handler associated with clicking one of these here, in that they trigger a different type of mutation state change, or they trigger a different action in the language of the user juicer hook. Now let's look at the actual code that does the body of the work, which is contained here. Here's my implementation of my reducer function, which I'm just going to skip over initially for now. And here's the main component, and here's my declaration of my state, but I'm declaring my state using the user juicer hook. And my state is going to be this object, which has a friends key and an empty array. That's my initial value for my state. I'm using the use effect to grab 10 friends from my random user web API. And when I get the data back from the web API, I call the dispatch function, which I get a reference from here. I call the dispatch function. So this is the first action that I want to trigger in order to carry out a state change. This is my initial state. But clearly I need to populate this array, but that constitutes a state change. So I'm calling the dispatch function, and the dispatch function from the slides, you pass it an action object, and an action object tends to have two key value pairs. One key is the type of action, And the names that you want to give to the actions is completely up to you. But I've decided that one of the actions associated with my particular application is the load invitees action. And the payload associated with it is the full array of friends that I got back from the web API. So when this executes, what it's going to do is, what the dispatch function does is, it calls my reducer function, which brings us up to here. And it calls it, and it passes in the current state, which is actually going to be my empty array of friends, and the action, which is what I've just shown you. And all the reducer does is it has a case switch statement where it looks at the action type. In my case, the action type was load invitees. So it's going to be this case that's going to be active for this particular invocation. And what am I doing? What you need to do, so here is where I'm mutating my state. And I said, what you need to do is you need to make a copy of the current state, carry out changes to that copy, and return that copy. Now, that is actually what I'm doing here, although it involves using the map function from before. So just to, I'm going action.payload. Sorry, let me just check this again now. Action.payload.friends. Action.payload.friends is going to be the full list of friends that I got back from the web API. I'm mapping over that array, and the map returns a new array. And what I need to do is I need to add this property to each friend, because I'm going to be using this property later on when friends start confirming their attendance and canceling their confirmation. So the only purpose of this here, I could really, if I didn't have to add on this extra property to each friend object that I got back from the web API, if I did not need that, then all I could have done here was just said that friends is initialized to, take out all of that. It's just action.payload.friends. That would suffice. But because I need to actually do some tweaking of the friend objects, that's why I added in this extra little bit here. But it's kind of the edge case, really. The loading of the friends is kind of the edge case, but it still follows that pattern of action, dispatch, and your user reducer, your reducer function. So let's just move on anyway from that. That's kind of part of the whole initialization, I suppose you might call it, that goes on. Let's go back to here. So I've got two local little functions here. And these are the two functions that are going to be triggered when I click on either a friend on the left-hand list or the right-hand list. And yet again, they're actually using the dispatch function. I suppose, well, okay, let's just park those for a second. Let's move on down. Here I'm just doing an ordinary computation. I'm computing what my list should be on the left and my list should be on the right by, again, when in this case I'm filtering over my array of friends that I have just put into the state. I'm filtering over them, and I'm using that extra property that I added on to work out has a friend confirmed that they're attending or not. Note the initial value I gave the confirmation, or the confirmed property, was I initialized them to false. And by initializing the false, that means all of my friends initially appear on the list on the left. But anyway, I'm just computing here my two lists, just using ordinary filtering. And finally, this is what my kind of home page displays. And I'm using the friends, I'm using the friend list component. I'm passing it down one of the arrays that I've just computed above. And I'm also passing down one of the event handlers that I mentioned above. This now is this event handler here. Because I said, if you remember, if I flip back here, the event handler associated with clicking one of these buttons is going to be different from the event handler associated with clicking on one of these buttons. And I use the friend list. I use this component twice. Why do I use it twice? Because I've got two different lists. If I follow, let's say, this one, this is the one that generates the list on the left. So I pass it down my array of friends, and I pass it down essentially kind of an event handler. This is the event handler that I want to execute when I click on the friend. And if I go right down to the friend component, that event handler eventually is passed in as a prop into my friend. And when I click on the friend, in the event handler, I invoke the event handler that was passed down to me. So action friend here at runtime, that is going to be bound to whichever one of these was passed down to it. So we're now at the stage where when we click on one of our friends, be it the one on the left or the one on the right, one of these two functions is going to execute. And not surprisingly, we want to carry out a state change, because as a result of clicking on a user, we want to change that user from whichever list they're on to a different list. But we implement that by means of a state mutation. So I guess if I follow this one here, so this is the event handler that will be triggered when the user confirms that they are going to attend. In other words, it's the event handler associated with each of these. And okay, we call our dispatcher. This time the action type is confirmation, and the payload is the actual friend object itself. And if I look at my reducer function, here's the confirmation case. This is where we carry out our mutation. And again, the mutation, okay, it's quite a loaded statement, but what am I doing? I'm taking my current state, I'm accessing the friends part of the state, even though there isn't anything else other than the friends part, and I'm mapping over that. Why am I mapping over it? Remember, the map function returns a completely new array. So the map is satisfying that requirement that I have, which is you cannot change the current state. You cannot change that array. You've got to create a copy of it and mutate the copy. And the map is actually doing that for me. And inside in the callback that I passed to map, essentially what I'm doing inside here is I'm waiting to find the actual friend that has been clicked on, and I set their confirmation to true, because they have now confirmed that they're going to attend. That's all I'm doing really inside here. So the map, if you like, the map is going to eventually it's going to return the exact same array as the friends array, with one difference. The only difference is the particular friend that I clicked on, their confirmed property is going to be set to true. It would have been false. And so all I'm doing here is waiting until I find the actual friend before I carry out this change. So the map was just convenient in this case, right? It won't always be as convenient as that in terms of mutating your state, but it just works nicely. And in fact, the other action The other action is when the user has confirmed that they're attending, but they've then come along and cancelled it. And we're doing actually, and it's only coincidental, this is almost a carbon copy of what I was doing above. And again, I'm mapping over. But in this case, I'm waiting to find the friend that has been clicked on, and I'm setting their confirmation back to false. So each of my friends, their confirmed property is either going to be true or false. And that's what allows me to, compute the list of people that are going to attend, or the people that are going to be absent. That's just how I designed it. Right. I also suspect that you will need to study this as well before you delve into this week's lab, because I use the use reducer in this week's lab as well. But this is as simple a case as I could come up with, really, without making it too trivial, really, if you like. I'll pause for a second just in case people have any questions. No, okay. That's the use reducer. You'll be glad to hear this is the last topic. Well, second last, actually. Authentication. So we're back to actually navigation again. But in this case, our objective is to try and declare certain routes within our application set of routes as being private or protected. And by private or protected, we simply mean that the user must have authenticated, must have logged in before they can access them. Fairly common requirement. How do we implement it? And if you Google around this, you get lots of solutions. And to be honest, that's what I did. And I came across one solution that I thought was quite neat in the way it implemented it. And I'm really just showing you excerpts from that. And I'm also giving you a complete implementation of it. The complete implementation of it is the last sample in our set of routing samples. So I need to load those up again. That's okay, don't need that. So we're now on to sample 9. This one here has the implementation of it. And it's a fairly standard kind of requirement, as I said. So if we look at the top left screenshot, this is my home page, and I've got some navigation links in my header. And the understanding is that anybody can navigate to the home page, anybody can navigate to this page, but if you try and navigate to either of these, then you're forced to log in. So if you try, and also at the very top, the application knows whether you have logged in or not. And you also have the option of just going straight to the login page by clicking on this here, rather than trying to get access to a protected or private route and being redirected to the login page anyway. Just remember that, right? I can go to the login page directly or indirectly, if you like, by trying to access these pages here. So if I do try and access, let's say, the inbox page, then I get redirected to the login page. I do my login and I click the login button, and the login assuming it's successful, my username and password match up, then I do get sent to the page that I was trying to get access to. So in a sense, the application remembers where I was trying to go to before it forced me to log in. A simpler solution would be you just send them back to the home page anyway, and then when they click on the inbox, they will be taken to the inbox page. But it's a slightly better user experience if the application remembers who they are, or remembers where they're trying to go and sends them there after successful authentication. But of course, you have to try and implement that somehow in your code. That's the idea. Oh, sorry. So we're now, our kind of overall header has changed. Okay, it now knows you're logged in and you're provided with a sign out button. And of course, eventually the user, and if we go to the profile page, it's going to be the exact same. We will be able to go to the profile page directly now if we want to. We don't have to log in again, obviously. And eventually, if the user clicks to sign out, then by default, they're brought back to the home page. As I said, fairly standard behavior. So the inbox page and the profile page were protected routes, but there's no actual way of implementing protected routes or private routes using the React Router library. It just doesn't provide a solution, unfortunately. So we've got to build our own kind of custom solution. And I suppose, you know, there's lots of ways we could approach it, but it would be nice if we had a declarative style there. I'm saying a declarative style to declaring routes that were protected and those that weren't, so that it was obvious to the person reading your code. So it would be nice if we could implement our routing configuration like this. So in particular, like if we could have these kind of entries here. So it's very clear what this routing configuration is telling me. These are public, these are private, and we can mix and match them any way we want to. But there is no component called the private route component. It doesn't come with the library. We've got to implement this ourselves. And again, the private route, its interface is the exact same as a route. You know, it has a path and a component, so it looks very similar, but behind the scenes, its behavior is different. That's kind of our objective. We need to implement this private route component to achieve what we want to achieve. So in terms of our overall solution, I'm going to use React context to store whether there is somebody currently logged in or not. It's a very, it's kind of an ideal use case for a context. Now, in my case, I'm just storing whether somebody is currently logged in or not, but typically you might store the user's username or maybe some other information associated with the user. But either way, we will store that in the context because there may be many components that actually need to know that. It may influence what they render in their main view, apart from the app-wide header. It needs to know it as well, but the other components may need to know it because they may need to use it. Number two, I'm saying we're going to need to have programmatic navigation. There's two use cases for programmatic navigation. We want to be able to redirect the user to the login page when they try and access a protected route when they haven't authenticated. And I think we also use programmatic navigation when we send them back to the home page once they click the sign out button. And we know how to do the second of those two. Number three then is this idea of how will we implement the app remembering where the user was trying to go before they were forced to log in. And so I'm just going to show you excerpts from the solution. You have the full solution code in the samples, and you can step through that later on yourselves. So this is the first part that I'm going to show you, the context where I'm storing whether there is somebody logged in or not. And, you know, it has familiar things here. I'm declaring my context. Here's my context provider. I've just decided that the state variable that I'm going to use here is just going to be a simple Boolean, I think. Yeah. So it's only really recording whether somebody is logged in or not, and it's initialized to false. Nothing interesting here. This function here, and I've kind of purposefully collapsed it because I didn't have enough room really, but you can look at the detail later on yourself. But it's kind of obvious, hopefully from the name, what this function does. This is the function that's going to be executed when the user fills in the login page and clicks login. So, you know, presumably gets the user's username and password and does something. Okay, it talks to a backend web API to authenticate them and either returns true or false. And if everything is fine, presumably inside here, I'm going to change the state to true if the person is a valid user to indicate now there's somebody logged in. I also have this function here, which is going to be triggered when the user clicks the sign out button. And it will also trigger a state change here, obviously. What else? That's it really. That's all I need up here. And here's the part that I'm making available to the part of my context that I'm making available to the rest of my components. I'm actually sharing what the current value of is authenticated is. Is authenticated is what I've decided to call my state variable, because as I alluded to earlier on, some components may need to know that in order to control what they display. And I'm also passing down the two login sign out functions that I've declared up here, because these are used elsewhere. Not intentionally now, but I've used a shorthand form of object declaration here. Sorry about that. This is, I am declaring an object here with key value pairs. When you use this shorthand form, what you're essentially saying is, I want to declare an entry in my object where the key is that, and the value is the variable called that. So this will actually, this line here will declare a key is authenticated, and the value of that key will be this variable up here. This one here is going to declare a key value pair where the key text is sign out and the value is a reference to my sign out function. It's a shorthand form for declaring objects where the key and the value have the exact same string, if you like, associated with it. I didn't mean to do that. No, sorry about that. But other than that, then it's just an ordinary context provider. So that's my auth context. This is the important one, really, if there is an important one. They're all important, but this is the component that implements private root. And essentially what this component needs to do is, it needs to determine, is there somebody logged in or not? If there is not a person logged in, then it's going to return a redirect component. If there is somebody currently logged in, it's going to return an ordinary route component. So if you like, if I may just go back, at runtime, this here is going to be replaced by either a redirect to, or it'll be replaced by an ordinary route. If it's replaced by an ordinary route, then the user can go to that particular page. And it will only be an ordinary route because the private route component has determined that there is somebody currently logged in. The second case is that the private route will be replaced by a redirect to component. And that's going to happen if there isn't somebody currently logged in. The nitty-gritty then is tricky enough, I suppose. So first of all, this private route component is a consumer of my context, which is why I've got this line here. What's going on here is I'm taking my props object. My props object is dictated by what's up here, right? It's taking the props object, and there may be other props as well as these two explicit ones. Okay, there may be other default props, as we know. So I'm taking the props object, and I'm particularly interested in the component prop. And what I'm doing is I'm declaring a local variable where the local variable is going to be called component with a capital C. And again, this was just a nicety in the solution rather than a necessity, but I'll explain it anyway. I'm declaring a local variable called component with a capital C. and that variable is going to be assigned whatever component you specify here. The rest, as we saw from last week, that is going to be assigned all of the other key value pairs in this props object, and I'm just spreading them, just gathering them together. I don't actually use this at all, but I do use this subsequently, as we'll see. So that's for that line. So it's a fairly packed statement, admittedly. There's destructuring going on there, object destructuring, and I'm also renaming certain keys. That's effectively what I'm doing here. Next, I'm checking to see, is there somebody logged in or not? So I'm accessing is authenticated from the context up here. So this is either, this expression here is either going to have the value true or false in it. And I'm comparing it to the Boolean true. And if that entire expression is true, which means there is somebody currently logged in, then I am returning a route. And here I'm configuring the route component. I'm sorry, I said I wasn't using REST, but I am actually using REST. This REST here is taking the object that was constructed here and it's spreading them out. So it's taking all of the props that were passed down to me, except the component prop, spreading them out. And I'm using the alternative form of the root, blah, blah, blah. And component here is referring to this variable here, which for this particular example is going to be assigned to this component here. So overall, I'm returning an ordinary route component, and because it's an ordinary route component, that means the user will be allowed to access that particular view. The else side of this kind of if statement here, albeit I'm using the ternary operator, the else side is return or redirect to. The path of the redirect is my login path. Now, what is going on here? Remember I said I want to try and remember where the user was trying to go to. And for this case, this was where the user was trying to go to. They were trying to go to the inbox/inbox route, but they were stopped. But I do want to remember that path. And that path is actually available to me as a special prop called the location prop. The location prop is a prop that's always available to us. We just haven't used it up to now. The prop is an object, and I'm showing you a screenshot of the object here. There's lots of data in there. The only part we're particularly interested in is there's a key called path name, and path name has the current path name that's in the URL of the URL address of the browser. So I'm essentially storing that essentially as additional data that will be available to whatever component gets mounted when the URL changes to /login. And because I'm using a redirect here, the URL of the browser is now going to change to /login. But inside of the component that is mounted to deal with this path, it will actually be able to access this entire object here. That brings me to the login page. The login page component, that's the component that will get mounted as a result of the browser's URL being changed to this. Here's the login page, and it's fairly ordinary. It does need to access the context as well. This is the function that executes when the user clicks the login button. And again, I've stripped it down really. Normally you would have some sort of validation of the user, I suppose. Well, in fact, sorry, no. What do I want to do? I want to call the authenticate function that I've defined above in the context. That's where I actually talk to the web API, passing up the username and password that was entered. And eventually that will either cause a state change above in the context or not. So that's an ordinary event handler that's executed when the user clicks the login button of the login page. What is happening here is I am extracting the path name that I stored here. Again, that's quite tricky. Can I first of all explain the general form of this statement here, which we haven't seen before? This is a JavaScript thing now. When you've got a JavaScript statement where you're declaring a variable and the assignment statement is of the form expression or expression. This is a JavaScript syntax now. The way this works is it evaluates this part first, and if that evaluates to true, and it will be true if this expression, for example, evaluates to an ordinary object, that would constitute true, then it will assign this expression to the thing on the left. If that evaluates to false, this expression evaluates to false, and one example when it would evaluate to false is if the entire expression evaluated to undefined. Undefined is considered false. Then it will assign this thing to what's on the left. And if you think about it, this will evaluate to true if we came to the login page as a result of the user trying to access a protected route. Whereas this will evaluate to false or undefined if the user accessed the login page by clicking on the login button directly themselves. If the user clicked on the login button directly themselves, then where do I want to redirect them to? I want to redirect them to the home page because I don't know where they want to go. And all I'm doing here is I'm kind of artificially constructing an object that is kind of similar to this object here. It has a lot missing from it though, because I don't need the extra bit. All I really need is the path name bit. Sorry, I'm trying to construct this type of object here. Beg your pardon. I'm trying to construct this type of object. And that's what I am doing here. And I'm setting the path name to slash. Again, quite a tricky bit of coding going on there. And then the rest is reasonable enough, I think, in that, okay, this is just displaying my login page. When the user clicks the login button, my click handler is this function up here. This function accesses the context. It accesses a function in the context. The context carries out a state change, and because the context provider carries out a state change, the context provider is going to re-render, but also this, which is a child of it, is going to re-render. And on that subsequent re-rendering, this if statement is now going to be true because the context will have set is authenticated to true. And what do we want to do? We want to redirect the user to where they want to go, or else redirect them back to the home page, depending on how they got to the login page. And that's why I'm returning a redirect component. A lot going on there. And I did say to you, I think last week, you might think implementing authentication and protected and private routes, because it's a very standard kind of requirement, would be straightforward, but you can see it's not straightforward. They are excerpts from it. I think you will need to, I think anyway, you will need to look at the detail here in sample 9, where you have all of the different elements, and I'm just showing you excerpts from it. Play around with it, stick in console.logs to follow the flow. And once you're happy with how you understand how it works, then maybe what you might want to do is, in terms of the assignment, you might actually copy and paste this code over to your Movies app, if it's the Movies app that you're targeting for your assignment, and you reuse it by all means. I want to cover one or two other little things. I'm really sorry now about this. Related to JavaScript and ES6. The first thing is this notion of what's true and false, and it actually relates to that last screenshot from the login stuff that I was talking about there. In JavaScript, if you look at the box on the bottom here, in JavaScript, you can have just an ordinary variable in an if statement. And we know how the if statement worked. If that variable evaluates to true, it executes this. If it evaluates to false, it executes this. But you can just have an ordinary variable. And I'm telling you in this box here, what constitutes true or false for a variable. Well, clearly, if the variable is a Boolean variable and it has the value false, then that's false. If a variable is a numeric variable and it has the value 0, the current value is 0, then that means false. So if value here was referring to a variable that had the numeric value 0 in it, then this expression is going to be false, which means it skips over and it executes this. If the variable value is null, that also means false. If it's an empty string, whether it be a single quoted or double quoted string, if it's an empty string, that constitutes false in the JavaScript world. If the variable has the undefined value, in other words, it's an uninitialized variable, then that's also false. And there's just not a number, which you needn't worry about. That's also false. So these are all by default false in the JavaScript world. What is true? Well, if you had a string that had the actual character 0, that's true. But really, this is kind of slightly more relevant. Any string, no matter what its contents is, that constitutes true. Again, so if this value here referred to a variable, and that variable, its value was some sort of string, then this expression would evaluate to true, and it would execute this. The empty array or the empty object, that's what these two things are. They are considered to be true values. Or even if the variable was referring to a function, that's also true. So these are the different true cases, apart from the Boolean true as well, which I've left out, which is fairly obvious. And these are kind of a throwback to the earlier days of JavaScript. JavaScript had a lot of unsatisfactory aspects to it, and one of them is in the whole area of when you're trying to do comparisons, there's a comparison operator, which is this double equals operator. Does it evaluate to true or false? And it was a real gotcha for lots of people. So for example, if you're comparing two variables and one variable has the integer value 1 and the other variable has the string 1, then as far as JavaScript in the early days, that expression was considered to be true. Now, you wouldn't think it should be, but it was. And there are other examples as well, like if you're doing this comparison here, that expression evaluates to true, this evaluates to true. The upshot of it is in ES6, they introduced a new operator for comparison, which is the triple equals operator. Okay, this is the double equals one. And the triple equals one is the one you should always be using. It's a much safer comparison operator. If I use the triple equals operator in all of these expressions here, they will all evaluate to false, which is really what we would expect. So the message is never use double equals, always use triple equals. But also it's important to remember these two boxes here, because you will, and you've seen in my code, I have this kind of stuff going on, whether it be in an if statement or in a ternary operator, or even if I might just go back for a second. Here, like that's what was going on here. So I kind of said, if this expression evaluates to true, well, now we know when that might evaluate to true and when it might evaluate to false. It would evaluate to false if this expression equals undefined. If this expression evaluated to any type of object, then it's considered to be true. And it doesn't assign true or false to the thing on the left. What it assigns is the actual expression itself. Maybe I didn't highlight that point. That's what's called truthy or falsy in the, that should be falsy really. In JavaScript, you can Google it yourselves and you can get some more information on it if you need. The very last thing I want to talk about is modularity, which I could have covered on day one, but I was kind of cut for time. Modularity, it's always a good idea to break up your code into modules, which really kind of means break it up into individual files. It's good for all of these reasons here. How do we actually, in the early days of JavaScript, we had modularity, but it wasn't baked into the language. We actually used a third-party library to do it called the Commons.js library. But as of ES6 and onwards, it's now actually kind of baked into the language syntax itself. And ES6 gives us two forms of modularity. Modularity, by modularity, we mean here now things that we export from a file and make available to other files within our code base. So there are default exports and there are what are called named exports. And here's some examples, all of which we've seen already in the code up to now, I suppose, but I thought it was important that I just highlight 1 or 2 points. So supposing I've got a file called lib.js and it declares a function and I want to make that function available to the rest of my code base, but it's the only thing within lib.js that I want to make available to the rest of the code base. There may be other things inside in this file, but they are private to the file. So if there's only one thing that you want to make available to the rest of your code base, then the way you export it is by saying export default and whatever the thing you're exporting is. It doesn't have to be a function. It could be a class, could be a constant, but it is just a function in this case. So that's how I export it. How do I import it? This is how I import it. I need to specify the path name of the file, the relative path name, the relative path name of the file that contains the thing that you're trying to access. They happen to be in the same folder, but they don't have to be in general. And the name that you assign to what you are importing, this function doesn't have any name, but even if it did have a name, when you import it here, you can give it a different name. You don't have to give it the name that it was given in the source file, if you like. So that's the syntax for default exports. So default exports are when you are exporting only one thing to the rest of the application. If you're exporting many things, then it's what are called named exports. So here we have many things that we are exporting from lib.js. And the syntax of the import then is slightly different. We have to wrap the imports in curly braces. Now I'm exporting many things here, but maybe inside here in this separate file, I don't want to import all of the things that are being exported here. There are only certain things that I want to import. So I'm only specifying 2 of them. The second point is you must know the exact name that was given to what was being exported here. So they do need to match up, whereas they didn't over here. But you wrap it in curly braces, and again, it's the path name of the file that contains the things that are being exported. So that's what are called named exports. Now, in both of these examples, I am importing from files that are local to me, that are part of my project in lib.js in this case. And when you do the import, as I've said, the from part is where you specify the relative path name of the file that contains the thing that you're importing. However, when you're importing a third-party library, what you specify is just the library name. You don't specify a path name here. And clearly, React is a third-party library that I'm importing. I didn't have to use that as the name, but it's the convention. So if you dug into the React index.js, then you'd find a heck of a lot of stuff there. But so that's importing from third-party libraries. But I'm importing. Well, sorry, what I can deduce from this, based on the argument I made up here, is that if I dug into the React index.js, then its default export would have been this React object. Okay, its default export. Third-party modules, we know how do we use third-party modules. We have to install them using npm install or er install. And we don't use a path name when we import them, as I already said. And so we have that. But down here, sometimes, and in most times actually, most times a third-party library is going to have both a default export and named exports. We can have it as well in our code. If I might just go back for 1 second. Here, all of my exports are named exports, but I could have had a default export as well. If I had a default export, and if down here all I wanted was the default export, well, I would use this form over here. When a third party or your own code has a mixture of both default and named exports, then how do you import them? This is the syntax that you use here, and you've already seen that, but maybe you haven't concentrated on it because it's just been a cut and paste. But the way you interpret this now is this third-party library, its default export was the React object or an object, which I've decided to call React. But it has named exports, which were specifically called this and this. So that's just how you interpret, let's say, that import statement versus that import statement. It's got to do with named exports versus default exports. And finally, this also works for your own custom modules, as I alluded to there. There was one or two other things that I wanted to cover, but it would be unfair of me now to keep going. So there's only destructuring in here, which we've already seen destructuring, and I've given you a hyperlink to a web page that explains destructuring. But you can look at these slides later on if you want to yourself. Is that all I wanted to cover? Yeah, it was. As usual, I go way over time, but you'll be glad to hear that this is my last lecture with you, so that's why I kept going. There is no next week. And sorry, no. Yeah, so I fairly ran through it. I knew that, but there's lots of supporting code that you will need to look through, which I definitely think he should do, and I'm sure you feel yourselves that you will need to do that. So we'll have the normal lab on Thursday, and it'll be the final part, as I said, and it'll contain user juicer, programmatic navigation, a lot of the things that I've covered. The render props pattern contains all of that stuff, which is why I wanted to cover them in the lecture first. It doesn't contain the private routes that's in the sample line, which you can look at. So you have an actual implementation of everything rather than just slides explaining them. Okay, folks, thanks for hanging on if you're still there, if you're still hanging on, and I will touch base with you on Thursday.
Thank you.
Bye for now.